Hello, everybody. Welcome to the last What Happened Wednesday for MAE 3724, Dynamic Systems Analysis and Introduction to Control. We're going to be going over closed loop control today. In order to understand closed loop, we first have to understand the concept of open loop control, denoted by this simple block diagram, where we have a controller C and a plant P. The transfer function for this open loop controller is y of s over r of s is equal to our plant times our controller. Note how there is no account for any error or change in the system and that this C is a set value. Now going on to our closed loop control, we have this block diagram with our same controller and plant, but we also have a feedback loop that takes our output and sends it back into our input. The transfer function for this closed loop control, y of s over r of s, is equal to pc over 1 plus pc, which accounts for the errors in the system. The generic model of the closed loop presented below in this block diagram takes our g and h, where g is our plant and our controller, and h is our error. The transfer function for this simple and generic model of the closed loop is g over 1 plus gh, where gh accounts for the error. When looking at control, we are also concerned about the tracking, sensitivity, and noise response of the system. Tracking, given by the Laplace transform or transfer function, y of s over rs is equal to L over 1 plus L, which is kind of modeled up here, where this L is our plant times our controller. Good tracking is denoted where this transfer function goes to 1, so we need to make this L term large, or our controller times our plant large. To have a sensitive system, we look at the error over the input, where it is equal to the ratio of 1 over 1 plus L, and it needs to be as small as possible to be very sensitive. So we minimize this to 0, which means that we have to make our L large again. Notice how a system can have good tracking and good sensitivity. Now looking at the noise response, denoted by Y over our noise, it is also denoted by L over 1 plus L, the same as our tracking. But noise response is good, and it has a good noise rejection when it's a small value. So in order to get this transfer function minimized, L has to be small. So we can only have good tracking and good sensitivity, but we cannot have good noise response with the other two. So we have to find a balance. Thank you.